Hello everyone, welcome to our meetup, Data Roots meetup. I'm Virginie, I'm head of Data Root Research, and today we have an awesome video about next generation bike fitting. So I will start by introducing our Roots Academy. Roots Academy, this is our program for young graduates, which we run every 6 months, so twice a year at Data Roots, and it's very nice training with 4 weeks intense training with our data specialist, which covers a lot of different topics like basics, the landscape, AI and data landscape. And we have then dedicated session to go more in depth, like data engineering, cloud native, and of course for machine learning, we have also a dedicated module for machine learning and ML ops. So we have young graduates working, getting trained at the Roots Academy, which is a very nice program. And after that, they get the opportunity to work on a co-project. And so today, Kiel, which is one of the participants, will present what was the project, the co-project that they did. It's a very short project. The goal is to test new technologies, to do a small project in the cloud. So I think it's going to be very interesting. Well, Kiel, I think you can start.
Yeah, I'll take over. Thanks for the introduction, Virginie. So let's introduce the people who worked on this project. So Janu, myself, Lisbeth, and Gilliam. We try to make a funny quote, so to break the tension a little. But I should say perhaps that me, Janu, and myself were involved as more machine learning engineers, and Lisbeth and Gilliam were more data engineers in this project. More specifically, Janu actually was mostly responsible developing and deploying the model that we used. I myself worked on the website, so the front end, the stuff you will be interacting with. Lisbeth focused on deployment, and Gilliam also worked on the deployment and the cloud architecture and how everything relates to one another. So with that being said, let's talk about what we did. So in Belgium, I don't know if many people from other countries are here, but cycling is a very popular sport in Belgium. And it's also a very popular sport in Data Roots. We have a lot of amateur cyclists who have professional great bikes that go biking daily or weekly, often long distances as well. But an important part in this sport is that your saddle is correctly adjusted to the height of your bike and to how tall you are as a person. Because if this is not the case, then you might get put strain on the knee, which can actually lead to some knee injuries. And so the idea here is that we want to provide amateur cyclists an easy, very cheap way to gauge whether or not they are correctly setting the height of their saddles, basically. So like I said, bikes can be expensive, but also the measuring equipment that is used by professional cyclists and their teams for these professionals to see whether or not they are in a correct position on their bike is really expensive. And that's not something an amateur cyclist who goes cycling once a week or maybe once every 2 weeks would want or can afford in some cases. So we thought that might be an opportunity to play with some machine learning and see what can come out of it, basically. So we have a really easy solution, which is just as simple as just uploading a video to our website that I described earlier. But let's just see what we're going to talk about in the rest of this session. So first, I will describe more in depth how everything works and how everything is set up. Then I'll go into the model output, specific results. We'll then take a more critical look at the model, so how robust are these results and what are some of the limitations that are imposed by the model or by our setup. And the last part of this session will be like focusing on how everything is deployed and the DevOps and everything around that supports the proper way that this all should run. So like I said, you upload a video and a video gets processed. We'll talk later about what processed means. The model that we use, it's a pre-built model. We only call it a library, basically. So these models analyze videos and then they return this kind of output, a video overlaid with this skeletal structure based on key points on the human body. And then using those key points, we try to find the position of the foot or the pedal at the lowest pedaling point. So in the cycling motion, the lowest point that the foot reaches. And at that point in the cycling motion, we calculate this angle that you see highlighted at the knee. So the angle between the foot and the thigh, actually. And why do we do that? Basically, there's some research, a lot of research actually, on this kind of topic, where this angle is a rather robust indicator or estimate of how well you are positioned on your bike. So to keep things simple, we focused only on this because, like Virginie said, it's been a short project and it's more about really playing or discovering new technologies more than actually developing some sort of product in the end. So when we then calculate the knee angle, we can give a recommendation. And here we base ourselves around this schema. So anything between 140 and 150 degrees, we consider a good height. This seems quite broad, but we have to leave some room for measurement error and stuff like that. And outside of those two, we either give them a recommendation to raise the saddle or to lower the saddle. So let's talk a bit more in detail. First, some pre-processing has to happen, of course. Video gets uploaded. We do some things with it to make it all easier for the backend to handle everything. So the resolution is reduced, the frame rate is reduced, and we only take the middle 10 seconds of the clip that is uploaded. So why do we do all of these things? Resolution one, the model that we use is really robust or really effective even when lower resolutions are used. Similar to frame rate, it can do it for pictures or for video. So in that sense, it doesn't really matter all that much. And then the middle 10 seconds, because as we'll talk about later, we did some testing and we discovered that 10 seconds was more than enough to get accurate estimates of the angle. And then also all of these things reduce the file size of the video, which increases the uploading speed and also the processing speed by the model. So it's like efficient on two fronts on why we chose to do this way. The next step, a bit obvious maybe, or not obvious if you're not so technically involved in these kind of things. So a video, the frames get the pixel values get put into a matrix, and then this is done for each frame. And this is what actually the model uses to do its calculations on. So that's that. Now let's see then what the model returns. So we get out what we put in, but added information in the matrices is now involving the information, the position of these specific key points. Makes it easier to deal with. And then of course, we get an overlay, but like I said, we need to find the lowest angle in the paddling cycle. So we do that by plotting or looking at the y coordinate, so the up and down coordinate of the foot. And then we use some basic mathematics to identify the local minima in this timeline. And then this of course, yeah, like you see, there's many points at the lowest angle. Of course, it's a video, so we gather them all. We calculate for each of those frames the angle, and then we take the average of all of those angles, and this is actually what is reported and what we use to make the recommendation. So we don't do it for one angle, one frame in the video. We aggregate a lot of angles because we think this reduces a bit of the measurement error or the model error. Like, not every frame will be exactly at the lowest point. So by averaging, we hope to compensate for this small amount of error that gets introduced. So how does the model work? I've been a bit vague about it until now, so let's make it more concrete. We used Movenet, which is, like I said, a pre-trained model. So it's like loading a library, basically. It was developed and by the nice people at TensorFlow, and they've also kindly made it available for everyone to use without limitation. And the whole purpose of this kind of Movenet model is to build these skeletal structures out of recordings. And this, as a field or as an idea within the machine learning world, is sometimes referred to as post-estimation. So this is like the architecture of the model. It's a bit complicated, so we'll not go too far in depth with it. So on the left, you see this kind of the input, obviously, and then some kind of two pyramids stacked to each other. This is the feature extractor. So this is what it will analyze the actual frames within the video, and then which will attempt to feed information to these 4 boxes you see on the right that will actually try to calculate these points as we saw them earlier. I think it's more interesting to focus on those 4 prediction heads, as they are called. And while this happens in tandem, as you see the line, it goes to all 4 of them at the same time. You can still conceptually think of it as like something that happens in a sequence, and that also makes it easier to understand and also explain for me. So that's what I'll be doing. So first, the center of a person is identified. So like the central point, the central point of mass in a person's body is identified by the first prediction head. And from this central point in the body, some lines are shot out towards the extremities, all the other key points that are interested, that are supposed to be used by the model. And then in the third step, because multiple people might be in the same frame, information about the distance from those key points away from the center. So like if a point is too far away from a center, that will probably be because it's another person and not the person that we are considering here. So this step 3, basically makes it so that the model can distinguish between multiple people in one frame or image. And then the last prediction head, the 4th, this basically does some small pixel level adjustments to make sure that each frame by frame everything stays as consistent as possible. Here this is a bit more in detail what I said. So step 1, you clearly see it's like the central point of mass of the body. Then these key points are cast out. And then, as you can see, like here, I'll use my mouse. There's a point here in the background. The distance from the person in the front to that key point is calculated and aggregated to calculate some kind of score that can make it easier for the model to say, oh, this person is here and this is another person. And then this is like the sub-pixel precision. See, a small adjustment can be done by the model to keep everything as correct as possible. So let's talk a bit about like robustness. This comes back to our pre-processing. So we reduce the frames per second, we reduce the resolution, and we only take the 10 seconds in the middle of the video. So why do we do this? Like, as you can see here, on the y-axis, so the vertical axis, you see the standard deviation of the estimate of angles. So what we actually did was we took a few videos, and for those videos, we systematically altered FPS resolution and duration into set specific values. As you can see here, so we made videos with, we turned one video that was filmed at 60 FPS, and we turned it into a video at 20, 30, 40, and 50 FPS. We also resolution, same idea, and then we did all of those combinations a little, which results in a lot of combinations, so a lot of data points for which a lot of videos for which angles were calculated. And it's for each of those combinations of values of FPS resolution and duration that we are interested in seeing, like, okay, like how far does this affect the spread of the distribution of the angle that we are interested in. And as you can see here, this isn't really impacted all that much. I also should say this line goes down. Sorry, the line goes up for like duration. It's a bit of an artifact, you might think, like a longer duration that should give you a more accurate assessment because you have more frames in a video. But here we think that's more of a statistical artifact because we didn't use that many videos to base these calculations on. So these estimates of standard error might not be that indicative, but overall we think we have enough evidence here to support that the model is quite robust to these specifications of the video, which is also helps us because not everyone has the same phone or the same quality of camera and will not film in the same resolution or for the same amount of time. So that really helps us ensure that a lot of people can get accurate results regardless of which setup they use, which camera they use. And then another question you can ask is like, how well does the model do when stuff in the frame in the video that you upload is different? You can think of, does clothing matter? Like a certain type of clothing might interfere. Is a model better for men or women? That might happen. Does something in the background make it? Can it influence the results? And the angle at which the video was shot, does that do something? We didn't have time to investigate all of these things, so we only focused on background sensitivity here. And we basically did this by taking videos and imposing a background on them. So on the left here, you see the original video, and then we use like video editing software to impose a background, and we try to make it like an indoor background and an outdoor background to see if that made any difference. And then we, of course, put it through our website and then or to our model, and then we see that these really don't have any. This doesn't influence the result at all. If so, yeah. But this is of course only for clothing. If we had time, we would go back to try and test more configurations. But it was only a few weeks of work. So let's now talk a bit about other limitations. So yeah, models are imperfect. Like I said, inaccurate estimates can happen. Also, we sometimes noticed some difficulties with the key points when they were so when the knee moves, it might block the other knee and then pop out above as you cycle. That sometimes confused the model a bit. We played around with it and tried to fix it, and I think it's now quite well. It's now working quite well. But so that's definitely something that should be kept in mind. And like as I said before, like, does the angle have an influence? Yes, it does. And I think I talk about this later as well. And if not, I'm happy to field any questions on it. So because of this setup that we use, the camera has to be at a straight angle, so like a 90-degree perspective on the person, because if you film from a different angle towards a person, the angles that we use to the angle that we need to calculate is influenced and changes, and then everything would get skewed, and that's not what we want. Of course, yeah, the whole person needs to be in the frame. I didn't talk about this, but we do some processing also to make so that we use information about the person's whole body to have an idea of in which direction actually their bike is set up, which had an influence on how stuff was calculated. And yeah, the bike has to stay in the same position. So like if the bike would move, if it's not a stationary bike, like I said, the angle changes as well. And that's something that we can't deal with because the way we calculate angles. But let's now talk about how everything is hosted and deployed. Like I said here, it's made with Azure, or we should say it's like hosted on Azure. The model, the Movenet model, is hosted as an endpoint on Microsoft Azure, and everything that the communication between the website and the model, everything there is also Azure. We tried to follow as much as possible MLOps best practices. So like we did Scrum, and then we tried to do the code versioning and ensure code quality. We wrote tests to make sure that our code does what it's supposed to do, everything like that. And because the last point, everything is deleted after the use. So because privacy is very important to us, Data Roots, nothing is kept. So when you upload a video, you get the results, and then once you close the session, everything is deleted. So we don't keep any information or video or results afterwards. So let's talk a bit more high level on how everything gets processed. So we go to our website, which looks like this, and then you upload a video. This video is sent to a storage blob on Azure, as said. And on this storage blob, there's an Azure function, which is something that is continuously looking at this storage blob. So you can think of it as like if you don't know what a storage blob is, you can think of it as like a folder in your computer. And we have some function or some program that is looking at a folder, or in this case, a blob, to see if a new information, in this case, a video, if a video is uploaded. And if it notices that a video is uploaded, it will talk to our machine learning model that is hosted on Azure Machine Learning. And this model will then go into action and get the video out of the storage blob, and then it can start doing its modeling, basically. And once that's done, a process that takes a few minutes, sometimes a few seconds, or up to a minute, results get sent to another storage blob. And while that is happening, our website is continuously looking at the last result storage blob to see if a result ends up there. I need to get it back to the website and actually display the result. Yeah, sorry, don't have a slide for that. So the result gets pulled back and it gets displayed on the website, and you get to see what the result is. So for deployment, we used Terraform and GitHub Actions because, yeah, this has some like a lot of parts that are moving, and so if we change one little thing, we don't really want to have to change other things. So that's where Terraform and GitHub Actions really help us keep everything nice and organized and streamlined, as well as the testing on GitHub. So that's all. As following modern like software development practices. So yeah, let's talk about what is value of the solution is. Yeah, we can prevent knee injury in amateur cyclists. It's really easy to use. It's a low effort. You only have to film a video and upload it. It's free. We won't be charging you money, and it will be open source. So I think today or later today, we will share the GitHub repository that has all of the code. So if you wanna tinker with it yourself, or host it yourself, or develop some extensions on it yourself, you are very welcome to do so. And now I'll show you just like a quick demo video of us interacting with the website. So I'll play it 2 times just to make sure that everything is done. So you drag and drop a video, or you can browse through your folder and upload a video. Here we explain the example setup again. So this is the kind of angle that we need to make sure that the model gets accurate results. So now everything is working. It takes a few seconds, and then yay, balloons show up, and then we get our results. So in this case, the person has to lower their angle, and then we provide another drop-down box that explains a bit about the methodology. Like I said, we take multiple angles and then we combine those and we take the average. It's interesting to see like how spread out those estimates were. And we do that by doing this histogram and overlaying normal density plots. And then we're also trying to make a video. It takes a bit longer, but this is a video that synchronizes the model, the position of the foot at each frame over time, coordinated or synchronized with the actual video. Yeah, that takes a bit longer to render. So we first provide the initial results, and then while you start reading those results, you get the processing happens, and then once you're done reading the results, ideally, or in this case, the video will be done, and you will have some insights onto like what's happening over time as well. But I'll just let it play one more time, and I think then we can start going towards a Q&A. So as you see, it's still running on the top right, like here. You see it's still running. And then once the video is done, you'll be allowed to scroll lower. The result will show up there. And then you can watch it. So there it goes. Of course, if your video saddle is not correctly specified, we say that you can upload another video with another specific with a different saddle height, and we'll of course we'll gladly check it for you, and hopefully that way you can zoom in onto what is a good saddle height for you. So yeah, that's it for the presentation. If there are any questions, I would love to answer some. Also, yeah, my colleagues will show up now because, like, of course, everything everyone is not up to date on every part of the process. So if there are specific questions about specific parts, Lisbeth, Helion, and Janu will be happy to talk about specific parts, and myself, of course, too. I see Yarik's question. Is there another one? No. So Yarik's question. So in terms of data science, this is a really nice project. Thank you, Yarik. Did you maybe verify the accuracy of the knee angles against bike fitting equipment as well? So I suppose you mean they're like professional bike fitting equipment. No, we did not, because we did not have this available. But I think there's a person in chat who might also have more to say about that.
Can you hear me?
Yeah, we can hear you.
Okay. So yeah, we had a time frame of 2 weeks, so we didn't do extensive testing. But we did have a few bikes where we knew that the saddle height was correctly set, and then we knew in advance what the angle should be, and then after the test it was around that same angle. So that's how we actually knew that it worked. But we didn't do extensive testing, and this should definitely be done if it were to be used more extensively. So yeah, other questions?
So I see a new question. Yeah, if you can, thanks. 140 to 150 degrees is a really big range, as your angle will also count for some of the saddle height changes. This will amount to 2 to 3 centimeters roughly, which is often far from optimal. This, I think, goes more into the biomechanics of it all, on which we're not experts. But yeah, you're right. It's not ideal, of course, but you have to keep in mind, like, it's a short project and it's a quick and easy solution. And we really only had the opportunity or the means to like only focus on one specific metric. We didn't have time to take into account how different points at the body relate to an optimal position on the bike. So that's unfortunately just a bit of the limitation that the time constraints forced on us as well, sadly. But like Heliam said, like if we had more time, there are so many things that we could improve upon and would want to improve upon, for sure.
But if you're going for a specific angle, you do get the angle back. So if you know, for example, you want to get 149, you can go for that, and the website will just give you the angle as well. Yes.
Okay, so a question by William. In the example, the output is down. Does that mean the saddle has to be lowered? Yes, it does. Does it also say how much? No, it doesn't, because that could get quite complicated really fast. We have to keep in, if we want to do that, we have to know the distance from the bike to the camera, maybe also the person's height, because otherwise estimates of the angle can differ widely. So that's something that sadly we couldn't do in this limited time frame either. But this is one of the first things that we talked about, like, do we want to provide an angle, like an estimate of how much you should lower? It would have been really cool, of course. But yeah, a bit once again, a bit limited there. I don't know if Janu or Heliam knows more about this than what I just said.
It's as you said, you need the height of the person to accurately kind of reference the angle to a specific distance. As for the last part, does the pants which are worn in the example video influence the eye? The model provided by TensorFlow is trained on a very large real-life data set with lots of different pants, so that should not be a problem. And we also tested it with different test videos where people wear different types of clothing.
Yeah, so we had people biking in like what you should consider or could consider like actual bike professional outfits, as well as just people wearing like yoga pants or jeans even, and that didn't influence the model at all, really. Maybe there's some kind of really freaky pattern that could exist that you could put on your pants that might throw the model for a loop, but not as far as we know currently. Cool project, very interesting. Thanks, Lode. Does the presence of cardboard Jonas have an influence on the optimal knee angle? So maybe for the people who don't work at DataRoots, I should clarify this a little bit. Cardboard Jonas is our CEO, our beloved CEO. And we have a cardboard cutout of him in the office, and we put it in random places. And when people open the doors, it can lead to fun situations. So we actually have some videos with cardboard Jonas in the background And luckily, no, it didn't influence the model at all. I think it wasn't even picked up at all as a person. Janu, do you remember?
It can be picked up, so the model can recognize multiple people, but it only returns the most central person. So if somebody walks in front of you in the video, that would be a problem. But the best input is video with just the one person biking. But people to the side should not be a problem.
Okay, I see in the chat that Jarek has a new question. I think it will pop up soon, but I'll already read it. Wait, there was another question first. Or is Azure ML the best option here? Maybe event grid of container apps could be used here. We use Azure ML to like host the model, so not really sure there. Maybe Janu knows more about that. And event grid, I think that's something that we considered, but then step down to Azure functions. Lisbeth and Helium might know more about that. Guys, any input?
So for the Azure ML part, as Giel said, we only use it to host a model, not to train any model, since it's already trained. So we could indeed deploy it on a simple container app. The model itself is deployed as a Kubernetes cluster. So that's the real deployment part. For the event grid, we could use event hubs or event grids indeed instead of a storage account. That would work very similarly.
I also see that Jarek came with a suggestion for the
so that's the question I saw that I wanted to read. If you want to go ahead, Helium, you can read it.
Yeah, it's a suggestion. It's a good suggestion. If all wheels are the same size, it's usually really, then we can then that could be a solution, right?
So it's this kind of information about people who really know a lot about that we could use to further develop it. So like this is like a proof of concept almost, and then I think expert input and feedback this would really make it even better. But yeah, it's a graduation project. It was not supposed to be an app that we want to put out to the world and make a business around or something, you know.
But it can be used. It can be built upon, right?
Yeah, it can be used.
It's already a very good layer of. Yes. Great. Any other questions?
So if people haven't seen it, or maybe we can repost them, or no, I think YouTube chat has the history, right? Even if you join late. I don't remember.
Yes, and the video will also be on YouTube.
The website, the website is posted on the chat. So if you scroll up, if you don't see it, you should be able to get on it and try it out yourself. And of course, we also posted our data roots research website where you can see like what data roots research is all about, and all the kind of stuff and initiatives that we are involved in and that we provide services for.
And there is also a GitHub repo that the link is just shared, so you can also visit that for more information and the code and everything else. There is also a blog post of it. I guess that's not shared yet.
People can find it through data roots research on the contributions part, but it might be nice if someone could post a link to the blog as well. It's basic. The blog is basically everything I talked about here, but in text form. Some parts a bit more written out than I had the time to go into here. But yeah.
Thanks a lot, Giel, for this great presentation. Thank you all for the for the questions. I think it was a very interesting topic. Thank you to everyone who has been watching us. And like Giel mentioned, we'll be back next month for another meetup. It's going to be about data governance and what this means. So it's going to be great. Stay tuned and we'll soon see each other back. Bye.
Bye-bye. Thanks.